Yeah.
Okay, so on number 10, D.
Yeah.
I feel like I have a pretty good grasp of everything in the lesson for the most part, but this one really stumped me. I wasn't sure. So we were finding the z-score here, but I didn't know. On all the example problems, I knew which one was like the sample mean and which one was the null hypothesis, so that I knew, x bar minus whatever I don't know the name of the symbols very well, but I didn't know what to do for the top part of my equation on this one, because I know there's 47, which is the
that's the mu, right?
But yeah. What would the other one be? So would it be 47 minus 47? I mean, there wasn't another.
You had to come up with that mean. You had to figure out what the mean was from those 15 numbers that they gave you.
Oh, so I used the mean of that.
Yeah.
Oh. Okay. Okay.
So what did you guys get for that? Because when I plugged in all those numbers, I did not get the answer they got.
I got 0.207.
Okay, negative, so what numbers?
7.
Negative. So my mean was 46.73.
Right.
So 46.73 minus 47 divided by 5 divided by the square root of 15.
Was it a negative 0.207 that you got, or positive?
I think it was negative.
That's why I got it wrong.
Let me look real quick.
Would the top part of that, sorry, I stepped away to grab my calculator. Would the top part of that be 47 minus 46.73 then?
No, the other way around.
You flipped around?
Yeah, because the 46 is the sample mean. The 47 is the population mean. So X bar is always the sample mean, and mu, the funny M thingy with the tail, is always the population mean.
Yeah, so it was negative 2.
I haven't checked my answers against their answers yet, so.
Let's see, I have them. Yeah, negative 0.207. I also wanted to. Actually, maybe I want to do this one over. Pull that applet and move it to the other screen. Yeah. So
I keep getting 0.209. How do I get that?
I got that the first time too. And how did I get 0.207? I think it was just in the math.
I added an extra 3, so mine.
Yeah.
I just did it to the third decimal point. So mine was 46.733. And so I ended up with negative 0.2068 and rounded it up to the 7.
Okay. I still get 209. Because I have on the top would be negative 0.27. And on the bottom, I have 1.291.
So 46.733 minus 47 is minus 0.267 divided by.
Okay. Maybe that's why, because I rounded that up.
0.268 is what I get. 0.2068 negative 0.2068, so 0.207. Yeah, you get an extra 3 there.
Okay, got it. And then I had a question on that same question. on the first one under the D there.
Huh?
Check the requirements. Since there are only 15 pieces of data, what will you need to check? I didn't understand how to check for something else, I guess.
Well, go ahead.
I was just going to say, somewhere in that lesson 9, I think it was towards the end, there was a thing that lists the steps in your hypothesis tests. There was like 11 steps, and one of them was verify that the requirements are met. And then at the end of all those steps, I think it said that you need to verify that you have SRS from a population and that your sample mean is normally distributed. And since you don't have a large sample, then you need to make sure that your population mean or your sample mean, you still need to make sure it's normally distributed. And it didn't look to me like it was.
Well, that's what it's left skewed, and so I didn't think that it was normally distributed.
Well, one of the things.
So that's what I was like, how do they get that?
So did you use the software, the Excel, to do that?
Did I?
Yeah. So if you put all of those numbers into that statistic, I don't know what the name of it is, but then down at the bottom, there's a tab for the QQ plots.
Okay.
Just go to that tab, and then you can see the QQ plot, and you can see that it's not normally distributed.
And I had totally missed that when I did it. I didn't even do that. I just saw that it was left skewed. But I should have used that and think about it.
So this is, and see, the answer is the sample mean is normally distributed, but it's not.
Is it? Is that the answer? I haven't checked mine.
Yeah, I think so. Let me check.
Does it state in the
I would have thought it was not.
Well, wait, let me check. No, okay, so what it shows us that Q plot.
Yeah, and that's
And
not normal.
maybe they're saying it is. I don't know. But I knew that was something that you're supposed to check. That's a requirement, but I'm looking at the bar graph, the histogram. I'm like, that's not normal. So, okay, whatever.
Yeah, they don't state whether or not it is or not, do they?
Yeah.
In the question, do they state whether or not over the nationwide population, whether it's normally distributed?
I didn't think so.
I don't remember
Yeah,
saying anything about it either.
I don't think it doesn't say anything. Huh.
So, Erica,
anyway.
did it look to you, looking at that QQ plot, does it look to you like it's normally distributed, or would you say it wasn't?
So I didn't know about the QQ plot when you type that into the equation. So that's kind of new to me. Yeah, I wasn't, that was another one that I wasn't sure about. So I'm not sure. I'll have to go and pull that up and kind of look at that, because I guess I just never saw the QQ plot down at the bottom of that. But I can do that right now and look.
So can we go over the V part of that number 10?
Part 5.
Compute the p-value.
The number 10.
Yeah, it's just it's just the next section of where we were just at.
Did you guys get your z-score as negative 0.209?
It's 0.207.
Negative 0.207. And I think that came from, so if you put your information into the Excel spreadsheet, then the mean that it came up with was like 46.73. But I went
Oh, okay, that makes sense.
negative 0.207 instead of.
Okay. Okay, so when we compute the p-value, we're going to go to that applet, right? And we'll plug in the z-scores.
And because we're just looking for a difference, not a more or less thing,
Both
we need
sides.
to make sure the ends are shaded, right?
Yep. So is it 0.836?
That's what I got.
Okay.
Now, why do we fill in this two sides again?
Because
So-
we're just looking.
Doing a less than or a greater than, we're doing
Different.
We're trying to disprove that.
Okay.
So
Right.
do you remember those 3 types of tests, Jennifer? You had the
Right.
right-tailed, the left-tailed, and the two-tailed.
And the two. Okay, yes.
This is
Yes.
two-tailed. If you think about it with tails, like both tails have to be highlighted.
Okay, that makes sense. Yep.
Both
Okay.
both ends.
Okay. Okay, so 0.836. I think the hardest part for this chapter for me is when they say use English to explain your answer.
I agree.
And I'm like, you know what? I don't speak the foreign language we're learning yet. So how do I translate that into English?
I agree.
So the thing that I get kind of caught up on is that level of significance. Do you understand that really well?
So I think when they give you that level of significance, it's 0.05, I guess, most of the time. Like this p-value is greater than that.
Right.
Right.
That means we, what does that mean? We do not reject the null hypothesis?
Right.
Yeah.
That's
And you know
right.
what? On one of my answers, I put we accept the null hypothesis. And I'm like, why do they say it that other way? And then like 2 more paragraphs, we never say we accept the null hypothesis.
But you can accept the alternative, right? So you reject the null and accept the alternative. Is that right?
Yes.
I think
Okay.
I was thinking we always mention the null hypothesis. We don't
Yeah.
ever say anything about the alternative.
There
So you either
was one question
reject it or do not.
I thought.
The last question, I think it was, said relate it to the alternative hypothesis. And that kind of threw me too. But then looking back, I saw that that's how they did it. They say there is enough evidence to suggest that that the age of the people buying the property is greater than, or there's not enough. I don't know. It's
Yeah.
weird.
I thought I had just read just a little while ago that you can, and I remember thinking, well, why can you accept the alternative, but because you can prove the alternative, and in doing, you reject the null, but you can never prove the null.
Right.
Is that right?
Like, did you guys see that? Did you guys get to that section where they do 1 = 2? And
No.
why did they even, and they ended up by doing math that 1 = 2. Seriously. But it really doesn't. This is the part of math 108 that I couldn't. Like, can we just move on, please? Let's go.
Yeah.
I want numbers in my math class. I don't want any English in my math class.
That's funny. So we would not reject, don't reject the null hypothesis,
We
right?
fail to.
Because there's insufficient evidence to support.
Yeah.
So the only way that we would reject the null hypothesis is if the p-value was less than.
Mm-hmm.
No, the p-value would be greater if we accepted it.
No,
Right?
Wait. Let's go back.
no, because on this one we fail to reject the null hypothesis on this one.
Yeah.
The p-value is the thing that tells us how apt we are to get an extreme, something as extreme as that. And so if we're not that apt to get something that extreme, then our null hypothesis is probably incorrect. And then we can reject it. But because this one was big, the null hypothesis is probably correct, and we have to fail to reject.
So
if the
p-value is smaller, then we don't reject it.
right, they had that little quote thingy. If the p is low, reject the null. So that's a good way to remember.
So, and so the other thing is, when we have the level of significance, is that just a number that we choose? I mean, there's no formula for that, right?
I think it's just given to us.
We're going to use 0.05 for our level of significance, or 0.01 for our level of significance.
Yeah.
I think there's like 3 numbers they said that are usually used.
Yeah.
The most often used one is the 0.05, because that gives us, what did they say, 1 out of
20.
Yeah, 1 out of 20 chance of getting a value that would be more extreme.
Mm-hmm.
And then if depending upon, whether or not you would rather have a test or a type 1 error or a type 2 error, if there was an error, then you would either pick the 0.01 or the 0.1.
Okay.
That makes sense?
Yes. Mm-hmm. Yeah. So I just have another question. Now it's just escaped me. I don't know. Can't remember. Oh well. All right. So do we want to go on and, I don't know, how are you feeling about all of this? I mean, are we good to open up the quiz? And
yeah, I think we should give it a whirl.
okay. Let me find my. I'm always.
And if there's any questions, or if someone's not understanding something, we have a lot of time. I mean, I don't think we're timed on the quiz. We can kind of break it down and work through it.
Yeah.
Okay.
Sorry, I'm slow.
Oh no, that's okay. I'm having a hard time keeping up. Where did everything go? Keeping all of my screens in order.
Yeah.
I open up one screen, I lose my Hangouts screen, and then I never know. I don't know. I just don't like not being able to see it.
Yeah.
Holy moly. This quiz is 21 questions.
Well, I'm hoping that some of them are as common as the ones that that were on the homework.
Yeah.
Okay.
All right, let us know when you get to question 3 and we'll get going on that one.
I'm there.
I'm there.
Perfect. Okay, so it says, which hypothesis involves equality? I believe that is the null
Yes.
Yeah.
hypothesis. Okay, the p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this information to answer the next question. Remember that the p-value is the probability of obtaining a sample statistic at least as extreme as the one that was observed. When computing the p-value, which hypothesis do you assume to be true?
No.
I would
Always
imagine
the null.
null, right?
Yeah.
Don't you always assume the null to be true unless
Yes.
there's
Yeah.
enough evidence to show that it's not?
Well,
Yeah, which would be at the end.
Okay. Okay, suppose the null hypothesis equals 10. Which of the following represents the alternative hypothesis for a two-tailed test? A two-tailed test would be C. Third one, I believe.
Yes.
Okay. Which of the following represents the alternative hypothesis for a left-tailed test? Wouldn't that be less than?
Yeah. A.
So A. Okay. And then right-tailed would be
Greater.
greater than. So B.
mhm.
Okay. Remember that we determine the outcome of a hypothesis test by comparing the p-value to the level of significance. Use this information to answer the next two questions. Which relationship would result in failing to reject the null hypothesis? Okay, this is the one where I have to look at my notes. I get confused.
Failing to reject. So when
Okay, so my
is greater.
internet went out.
Oh, no.
Oh, shoot.
So and now it's back on, but I 4. Did we put the null hypothesis for that?
On 4?
Yes.
Yes.
Okay. And so are you guys on 5 or further?
We're on 8.
We're on 8.
Oh gosh.
We can go back. It's
Okay.
okay.
All right, we'll just catch you up.
Okay.
So 6 is we put A.
Okay, so I'm on 5. Is that C for 5?
Correct.
Okay. And then 6 is A.
Yep.
Okay. And 7 is B. No, yes, B.
Yep, you got it.
Okay, now I'm caught up.
Okay, so I'm assuming that is that an A for alpha?
Alpha, yeah. So I think the
It
answer
looks like an X.
It does kind of, but yeah.
Yes, but that's
I
alpha.
like
Okay.
A.
Okay, so if we reject,
If the P is low, reject the null.
okay, I just need to write that down because I like that. If the P is low, reject the null. Okay, so which relationship would result in failing to reject the null? So this would be the P value would be greater than the null, right? So A.
yes.
That's what I have.
A.
Okay.
Yes.
I had to like reverse that in my mind there for a minute.
Mhm.
Okay, which relationship would result in rejecting the null? So again, if the P is low, reject the null. So the P, so it'd be B.
B.
Yeah.
Cracks me up that they put a B there. Just
What?
the P value is greater than B, or the P value is less than B. And I'm like, that's, I don't know. I guess you could put in L or a K or I don't know. Anyway.
Okay, let's see. Question 10. Does someone else want to read, or you guys want me to keep going, or?
You're doing
You
good.
did a good job.
Okay. An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim was $1,500. They are concerned that the true mean is actually higher than this. Which of the following would be the appropriate alternative hypothesis? So we're looking at, they think that it's higher. So it's going to be, the average claim amount is greater than $1,500.
Yeah,
Is that what you guys think?
that's what I think.
Now say that. So what is the null hypothesis?
That the claim equals that the mu equals 1,500.
Yep.
It equals 1,500. Okay.
So the alternative
They think
hypothesis is that the mu is greater than.
it's greater than. Okay.
Yep.
Okay.
Okay, which of the following would be the appropriate null hypothesis? It would be that the average claim amount then would be equal to $1,500.
1,500.
So that one always assumes that it's true, and then the other one will, based on how it's worded in the question, will be not equal to, which would be different, or greater than or less than, depending on kind of how it's worded.
That's right.
That's my understanding.
Okay.
Okay.
All right. The insurance company randomly selects n equals 40 claims and calculates a sample mean of $1,650. Use the information to answer the next 3 questions. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? I would say yes because of the large sample size.
Yeah.
And the so it's a good assumption since the sample size is large. So A.
So it doesn't, yeah, because it never says whether or not the population
It's normal.
Right.
Right.
So we have to go by the sample size.
Okay.
Okay. Oh, brother.
All right. What theorem or law justifies your answer? Ooh, we're taking it back. Isn't it the central limit theorem?
I think it's the law of total probability.
Let's go with C and let's see what happens.
Let's go see.
I think it's
I'm
the
embarrassed.
central limit theorem.
I think it is the central limit theorem, but I'm going to go back and just double check it because I always kind of.
Because the law of large numbers
Yeah.
has to do with the accuracy being close to.
The sample mean.
The limit has to do with the shape.
Yep, so it's definitely the central limit theorem.
All right.
Which of the following
Because of,
Oh, sorry, go ahead.
I was going to say, now, why is it the central limit theorem?
Because the central limit theorem has to do with shape,
Shape.
which is the distribution, and the law of large numbers doesn't have to do with the shape. It has to do with the
Accuracy.
Spread.
the spread.
Okay.
So the question is that the question above is that the insurance company assumes the distribution of the sample mean is normal. And so if it's normal, then the shape is going to be the bell curve. And so the central
Okay.
limit theorem deals with the shape.
Shape. Okay, gotcha.
Okay, are we all good on 14 now? Number 14?
Yep.
Okay, it says, which of the following is the test statistic as defined in this lesson? So the test statistic is the z-score.
Right.
That's what I gathered.
Yeah, I've got that in my notes, that the test statistic is the z-score. Yeah. You guys agree with that one?
Yeah. Mhm.
Yeah.
Okay. Okay. Okay, let's see here. I'm just going to read the question. Is that all right? What is the z-score associated with this test? Okay.
Okay.
So it gives us... Okay.
Standard deviation.
So the mean is $150.
Mhm.
The standard deviation is $40. The manager suspects the average is decreased. Okay. Compute it. Okay, so just so that I'm doing this right again, because I always mix up which one goes first, it's going to be 144 minus 150 for the top, right?
Right. Yes.
Right.
So the formula is always x bar minus mu. So
Okay.
that's so the you know your historical mean is always going to be the one that you're subtracting.
Okay.
So I get 0.9.
I
got-
got negative.
Negative
0.9.
0.9.
0.
Negative 0.9.
Yeah, negative 0.9.
So the answer will be negative 0.9.
Yeah.
No.
That's
You,
what I
you
got.
have
Oh, I'm sorry.
you have point.
0.9.
Negative
Point.
0.9. Is that the same thing? Negative 0.9? Negative 0.9?
Yes.
Okay.
So
Okay.
I z-score. Oh wait, and this is. I have to go back to the question.
Yeah, what do they want? Let's see. Is it decreased or?
So it's only going to be the left side, right?
That it is. She suspects that it has decreased. Yes, so we're only going to highlight. It's going to be left-tailed.
Left.
Yeah. So
Right.
I have a 0.1841.
So 0.184 will be the answer. Is that what you guys got?
That's what I got.
Yes. 0.184.
Okay. So, but the z-score that I get is 0.9. So that's number 15, right?
Make sure you put the
Yes.
negative in. It's
Negative.
z-score is negative 0.9.
And then 16 will be 0.184.
Mhm.
And then what inference would you make about the null hypothesis? So
It would fail to reject the null. Is that right?
Because it's higher than the alpha.
So we
we're
failed
not
to reject
rejecting
it.
it. Failed to reject. Yep. If the P is low, reject the null. I'm going to be saying that in my sleep. If the P is low, reject the null. What is your conclusion? So it would be
I put C. I put C.
yes, it is C.
Yeah.
Because we would then have it says, so if we don't reject it, then we have insufficient evidence to say that the population mean is less than 150. And it wouldn't be A because they're not saying that the population mean is 150.
Yeah.
They're saying that it's less than 150.
Mm-hmm.
Okay. There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? What is that here?
Type 1. The way I remember it, and I don't know if it'll make sense to you guys, is type 1 only has one negative because you reject the null hypothesis when, so you're only rejecting, there's only one negative. If it's the other one, then you're falsely rejecting the null hypothesis or something like that. Let me find my sheet if I wrote it down on here. You're failing to reject a false null hypothesis. So you've got like two negatives in there. Or
I don't have a question.
Reject a false.
18.
I don't know if that makes sense.
What?
Okay.
Jen, did you cut out again?
Okay, the way I remember it is a type 1 error has one rejection. You're failing to reject the null hypothesis. No, you're rejecting a true hypothesis, type 1. A type 2 error has like 2 or 3 negatives in it. You're failing to reject a false negative hypothesis. So if there's lots of failings and rejectings and falses, it's a type 2. If you're just rejecting a true one, it's a type 1. I don't know if that makes sense. But
Yeah, that helps. Jennifer Ward, are you there? Can you hear us?
I can hear you now, but
Oh.
like again, I didn't have an answer on. I'm on 18.
Okay.
Okay.
Go back. So on this one, we have insufficient evidence that the true population mean is less than 150.
Okay, so how does that work exactly?
So we've failed to reject the null hypothesis. Right.
Because the p-value is small or larger.
The p-value is larger than the than alpha. So
Okay.
so when we have sorry, so when we fail to reject it, what that means is that we didn't have sufficient evidence to reject it. So we have insufficient evidence that the is less than 100.
Okay.
I just have in my notes, basically, when I wrote down all the steps to solving, the last one is stating the conclusion. And I just put in there in my notes that if you reject the null hypothesis, then we have sufficient evidence to say, and if we don't reject it, then we have insufficient evidence to say whatever the claim was.
Okay, that makes sense.
So, I mean, I knew that just because I mean, that's what I had written down. So I don't know if it helps you to kind of write things down and then.
Okay, gotcha.
So if you reject the null, then you have sufficient evidence to say that the claim was, to say the claim. And if you don't reject the null hypothesis, then we have insufficient evidence.
Okay. Okay. And then question 19.
We put type 1.
Right. I put on type 1 and type 2. I put I had it written out so that whatever they're saying, if what they're saying is the opposite of the null hypothesis, then it's type 1. And type 2, if what they're saying is the null hypothesis at first, then it's type 2. So that's how I remember it. But I think everybody has their own tricks, right?
Yeah, I think both of those tricks are good tricks. I think they both would work.
I just have to make the chart. I have to visually make the chart. So then I can okay,
Yeah.
I can do it.
Okay, so are you guys on 20 or 21?
We're on 20.
Yep.
20, okay.
20 says that a researcher decided that instead of using a level of significance of 0.05, he will use 0.01. Which of the following will be true? Okay, I have this written down somewhere.
Probability of a type 2 error will increase. Did we lose Jen again?
Is Jen gone?
No. That's spotty internet today.
I still see Jen. Well, she's being very still.
Okay, researcher says it. Okay, so the level of significance went down.
So
if
that type error,
which would mean type 1 errors go down.
That's my understanding.
type 2 error goes up. So they just are kind of like this. So if one goes up, the other goes down.
Nice. So it'd be B.
Uh-huh.
Yeah.
That one's kind of tricky to wrap my brain around.
Yeah.
Because, like, the definition of alpha, the level of significance, is the probability of a type 1 error. So that's,
Yeah.
I gotta remember that.
So yeah, so when that probability goes down, then your probability of a type 2 is going to increase.
Yep. Because it has to do whatever the other does, the other has to do the opposite, right? It has to kind of go back and forth. Is Jennifer Ward there?
No.
Nope, she's gone now.
Do you think I should just text her that we put B for 20?
Okay. Oh,
I'll just send her a text.
I have my phone on airplane mode, so nobody. Oh, there she is.
She's back.
Oh,
Jen, you with us? You with us, Jen?
Volume is working.
yeah, I'm not sure that. She just texted and said that her internet went out again.
Tell her we can see her.
Okay.
And we put B.
I just texted her and said we put B for 20.
Oh. Are you there, Jennifer? Jen?
She said thanks.
So I guess we'll just do that for 21 as well. We're almost to the end. Do you think we should just go on, or should we wait?
No, let's just keep going.
If alpha is 0.05, compute the probability of committing a type 1 error, round to 2 decimal places.
That'd be the 1/20th, wouldn't it? So 1 divided by 20.
It's 0.05, isn't it?
Yeah.
So are they asking us to compute the error based on this information up here?
I'm confused on this one.
Yeah.
What were you doing, Jennifer, with a 20?
Well, it's 1/20th. If you take 1 and divide it by 20, you get 0.05. It's 1 out of 20 chances that you're going to have a type 1 error. So I think
It's 0.05.
0.05 is the answer.
So it's just the same thing that they're giving us, 0.05.
I think so. Because didn't you say that the definition of alpha was the probability of committing a type 1 error?
Yes. Yes, she did. So I think you're right. I think it has to be 0.05.
Jen, can you hear us? I can hear when she's turning her papers. And stuff. Okay.
That would be my best guess. Do you guys want me to submit it?
Sure.
All right, I'll submit it real fast, and because I mean that's basically all we know about alpha, is that it's the level of significance and it's the probability of committing type 1 errors.
Yeah.
Okay, I'm gonna submit it real fast and see what what happens. It's right. 23 out of 23. I'll text Jennifer.
Oh, I'm almost done doing that.
Okay, perfect. And just tell her we submitted. Good job. Read my mind.
Yeah, I just said, yeah.
Perfect.
Okay. Well, this is super helpful.
All right.
Thank you guys, for doing this. And have you finished the homework then, Jennifer?
Which one?
You.
Me? I haven't even started the homework. I just barely finished the
Oh,
Prep.
prep. Yeah. Before.
I haven't started the homework yet either.
okay.
Yeah.
All right. I think I'm on number 12, but anyway, this was helpful, and I will probably go back through and reread because I don't know. I'm barely keeping my head above water, I feel like. I feel like what I really need to do is clean my entire house so that I can straight up go.
It's amazing how much that can help sometimes.
Oh my gosh, yeah, I know. Anyway, okay, well, I'll stop the broadcast. And is there anything else that we need to do?
Don't think so.
I guess
Yep, I
if
think
we
we're
have
good.
any struggles, we can just text back and forth with homework problems and.
Yep.
Okay, sounds great. Have a wonderful weekend, and we'll see you on Tuesday.
All right. Thanks, guys. See ya.
Bye.
Right. Bye.